Here we have AP calculus AB problem. Okay, let's go the information. If the radius of a sphere is increasing at the rate of 2 inches per second, how fast in cubic inches per second is the volume increasing when the radius is 10 inches? Here there is an information that is the radius of a sphere is increasing at the rate of 2 inches per second. So that is the radius of a sphere is getting changed with respect to time. Since the radius is getting changed with respect to time, it can be written as a derivative, that is dr over dt equals to 2. So now let's understand the meaning of this derivative. So here r represents radius and this t represents time. So dr means the derivative of r. So how the radius of the sphere is getting changed with respect to time? So that is equal to 2. So here we write a positive value because the radius is increasing. In case the radius is decreasing, we have to write a negative value over here. Okay, now we have to find how fast in cubic inches per second is the volume increasing. That is, we have to find how the volume is getting changed. So for that, again, we have to find the derivative of this volume with respect to time, because they are asking us to find how the volume is increasing per second, that is with respect to time. For that, first let me write the formula to get a volume of a sphere, that is V equals to 4 over 3 times pi times r cube. Okay, since we have to find how fast the volume is increasing in cubic inches per second, we have to find derivative on both sides of this equation with respect to time. When I find derivative of this v with respect to time, I'm getting dv over dt. On the right side, r is a variable and this 4 over 3 is a constant, this pi is a constant. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is and find the derivative of the variable alone. So now what I have to do is I have to keep the constant 4 over 3 pi as it is, because both of them are multiplied by the variable. Let me keep these constants as it is. Now, when I find derivative of this r cube, I have to use a power rule. So that is, I have to bring this exponent 3 in front of the variable r and subtract 1 from the exponent. Then I'm getting 3r square. So far, I have completed derivative only for the exponent 3. So by chain rule, I have to further derivative of this r with respect to time. When I do so, I am getting dr over dt. So because we find derivative on both sides with respect to time. Okay, here this 3 and 3 will cancel out. I'm getting dv over dt equals to 4 times pi times r square times dr over dt. So our aim is to find the value of dv over dt, which gives the rate of change of volume, that is how volume is increasing in cubic inches per second. So now on the right side, we have to plug in the values we know for this r and this dr over dt. Already we got the value of this dr over dt, so that is 2. We can plug in this 2 for dr over dt. And also the question is asked us to find how fast in cubic inches per second the volume is increasing when the radius is 10 inches. So we have to find the rate of change of volume when the radius is 10 inches. So that is, we can plug in this 10 for the r over here. Okay, let me continue. d over dt is equal to 4 pi. We can plug in 10 for r, then we get 10 square. And for dr over dt, already we know the value, it's t. So dv over dt equals to 4 pi times 10 square is 100 times 2. dv over dt equals to, so we can multiply this 4 times 100 is 400. 400 times 2 is 800 pi. So I got the rate of change of volume. Now we have to write units for this value. Let's consider this dv over dt. So in numerator we have v, so that means volume. So always the unit of volume is cubic units, but here we have the radius in inches, and also they are asking us to find the rate of change of volume in cubic inches. So the unit of this volume v is cubic inches, and the unit of t is second. So because it's already given over here in the question itself. So cubic inches per second. So the volume is increasing at the rate of 800 pi cubic inches per second. So here we are saying the volume is increasing because we got a positive value over here.